Welcome to the course on statistics with Python. So before moving to the course, we need to study in detail about statistics because this is the foundation for data science as well as for machine learning. So once only we have a firm grasp on statistics, we can learn machine learning as well as data science. So our first step is to master statistics. Okay. So before delving into the details of this course, let us first see what you mean by statistics. Okay. So statistics is a branch of applied mathematics that involves the collection, description, analysis, and inference of conclusions from quantitative data. So the first step is the data collection. Okay, you can collect some data. Okay, that is the first step. Without data, there is no statistics as well as data science. So once you have data, you need to collect it and you can analyze it and you can make a summary of some of the data, and also you can make some inferences. So this is all about statistics. Okay, so based on this process, you can classify statistics into two types, that is descriptive and inferential statistics. So in this course we will study about both descriptive as well as inferential statistics. Descriptive statistics means, okay, that means we will study about that in detail in another video, but let us see, this is basically summarizes data. Okay, so that is all about descriptive statistics. So I will explain what all we are going to study. So in descriptive statistics, we will learn about various measures of central tendencies, measures of dispersion, measures of shape, measures of correlation, etc. And then after descriptive statistics, we will move to inferential statistics. That is the most important part, that is the foundation of machine learning. So in inferential statistics, we will learn about various types of hypothesis testing. Okay, so there are several types of hypothesis testing like parametric and non-parametric. That depends upon the type of data, right? Then, and in hypothesis testing, we will learn about the different types of test. So in parametric testing, we will study about different types of test like one sample test, two sample test, three sample test, etc. And also you will learn about regression. That means you will learn about both linear regression and logistic regression. Okay. And we will use Python to implement this linear regression. Okay. So this is what we are going to study in this course. Okay. Now, once you have understood what all we are going to study and what is some preliminary understanding about this statistics, now we can move to our first step. That is, we need to learn about data. So that means our first step is to study about types of data. Okay, so in the next video, we will discuss about the different types of data. So in the last video, we have seen what is statistics. So statistics is basically a process of collecting and analyzing data to make some inferences. So to analyze data, first we need to see what are the different types of data. So data can be classified into different types based upon its purpose. So let us see what are the different types of data. So this is generally classified into 4 different types. So it's very important to know what are the 4 important types. So these are the nominal data, ordinal data, interval data, and ratio data. So first let us see what is nominal data. So nominal data, let us see that in detail. A nominal scale classifies data into 2 distinct categories. That means an example is, for example, gender. It can be male, female, or transgender. So there is no rank between them. All are equal. Okay, there is nothing you cannot do any ranking, subtraction, multiplication, etc. For example, the marital status, it is either married or unmarried or single. So that is a nominal data. Okay. So when we move to ordinal scale, you will understand it in detail. So this is a nominal data. We don't have much use with nominal data. Okay. And what do you mean by the ordinal data? So ordinal data classifies data into two distinct categories in which you can apply some kind of a ranking. That means, for example, you are asked to enter the product satisfaction level. That is normally we do. Okay, you can rank it as satisfied, neutral, unsatisfied, etc. So there is some kind of a ranking. That means satisfied comes under the top, neutral in the middle, and unsatisfied in the bottom. You can give some numbers also, 3 to 1. Okay, so this is ordinal data because there is kind of ranking between them. So in nominal data, you did not have that kind of a ranking. And another example is faculty rank. For example, professor, associate professor, assistant professor. So there is a kind of a rank between them. The professor being the highest one and the associate professor being the second highest. Then comes the bottom level, that is the assistant professor. And student grades, it can be A, B, C, D, F, etc. A being the highest, B second. So there is a ranking. So you can establish some kind of a ranking between this data. So all that type of data falls under the category of ordinal data. Now comes the interval scale. Okay, so let us see. So interval scale and ratio scale are the two different types of data that is much useful for a data science student or engineer, data engineer. So let us see what is an interval scale. So interval scale is an ordered scale. Okay, there is also a ranking between them, in which the difference between the measurements is a measurable quantity. Okay, so let us take an example. Okay, for example, year. So let us take the case of year. For example, the year is 1981 and then year is 1985. So there can be difference of 4 years. But what is the true bottom? So you can go back to maybe 0, but you can even go back to BC. Like there is no true bottom. Okay, but there is a ranking, and also that difference also has got a meaning. But in the case of a ordinal scale, for example, if you take the associate professor and assistant professor, there is a ranking between them, but there is no difference. Difference does not carry a meaning. Okay, take the case of a temperature in Fahrenheit and Celsius scale, not in Kelvin scale, because Kelvin scale has a true bottom. In the case of a Celsius, 32 degrees Celsius, 0 degrees Celsius, 0 degrees Celsius is not the ultimate bottom, but the difference carries a meaning. 32 minus 0, that is 32 degrees. Okay, so these are called the interval scales. Okay, now we come to the highest category, or the ratio scale, that is mostly used. It has the maximum use in data science, that is the ratio scale. So ratio scale is an ordered scale. Again, this is an ordered scale in which the difference between the measurements is a measurable quantity and the measurements have a true 0 point. Let us take the case of a weight. Okay, weight is 20 kg. Weight can be 40 kg, and the true bottom is 0 kg. You cannot go below that. Similarly, age 20, 40, maybe 2, and also there is a bottom, that is 0. Similarly, for salary also. Okay, so these are the different types of data. Okay, so let us see one more thing, that is, okay, So we have seen 4 different types of data. We can let us call that data level. I told you this is the highest level, that is the ratio, then comes interval, then ordinal, then nominal. So what are the operations you can do with this data? Okay, nominal data you can classify and count. So like that means you classified into male, female, transgender. So there are 3 different categories. You can just count and classify. You cannot do any other operation. Okay, so later we will learn about some statistical methods. So like parametric and non-parametric. So that comes under inferential statistics. And in that case, if the data is nominal and ordinal, we will use non-parametric methods. And if the data given is interval or ratio, then we will use parametric methods. So we will learn in detail about that in another video when we learn about inferential statistics. Okay, so coming to the ordinal data, you can see here ordinal data we have seen like the product satisfaction level, like satisfied, neutral, not satisfied, like that. So there is some kind of a ranking between them, and you cannot have a difference between them, right? So that means all the above, that is the what all operations you can do. You can classify it, okay, you can count it, and you can rank it. That means this has got the highest rank, this is the second highest rank, this is the third highest rank, like that. You can rank it, right? Now coming to the interval data. Okay, interval data, that means we have seen example of year, that is 1981, 1985, like that. So here you can classify it, you can count it, you can rank it, and also you can do addition and subtraction. You can subtract it 4 years. The difference is 4 years, it carries a meaning. That means you can add and subtract it. Then comes to the ratio. So in ratio scale, you can do all the operations like classifying, counting, ranking, addition, subtraction, plus multiplication and division. Let us take the case of a weight 20, 40, 50, etc. So you can subtract it, we will get 40 minus 20, 20. If you take the ratio, that is 40 by 20, it is his weight is 2 times that of me, you can say like that. So that operations can also be done. But in this case, 1985 minus 1980, you cannot do that, right? So this is called the data level. So you should know the type of data and the level of the data that you are getting or collecting. Based upon this data only, you can make some inferences or you can conduct some tests, etc. So you can see for interval and ratio tests, you can carry out parametric test, and for nominal and ordinal data, you can only have non-parametric test. So in the coming video, we will learn in detail about the different types of test.